Hi, today I explain the basic concepts of work, power and energy for class 9th class students from classical mechanics, a part of general physics. These three concepts are very important in science and technology and plays vital role in science. Generally, people think reading, writing, drawing are works and consider are all energy consuming, but scientifically, no work is done in these activities. Then, when shall the work be done? Let us discuss. Before going to understand the scientific conception of work, question these three. The first one, what is the work being done on the objects? What is happening to the object? Who is doing the work? These three answers help us to understand the scientific conception of work. Suppose someone pushing a pebble on the road. What is the work being done here? For the answer this question, the work being done on the pebble. The second question, what is happening to the object? Clearly, we know the pebble is moving on the surface. What is doing the work? A person. A person is doing the work here. A person means here force. Object displaces. Work done. For the second question, someone lifting a book. Here, the work is being done on a book. A book is ready to moving on the surface. A person here lifting a book. These three are answers to these three questions. And another example, someone pulling a trolley on the surface. The work is being done on trolley here. When a man pulling a trolley moves along the direction of man. And who is doing the work? Here, a man is doing a work, like pulling a trolley here. So, according to these three answers to these three questions, help us to understand when the work is done. Concluded mainly three conditions. The first condition, to work done, the first condition should be applied. A constant force must be applied on the object in the nature of man or machine, whatever it may be. The second condition, the object must be moved from one place to another in the direction of force applied or make some angle. When the two conditions are fulfilled, definitely there is a work done according to the scientific conception. That is the meaning of work. Again, a closer look at the above situations tells that two conditions needed to be satisfied for work to be done. A force should act on the object and the object must have displacement in the direction of force. Now I explain how the work is done. A constant force applied on the object in the direction showed here. Then object displaces a distance and reached the position. The object got the displacement d or s. So what happened here? According to these two conditions, the force is applied on the object and the displacement is also happened. So the work done is here is W is equal F into S. The units of work done is Newton meter in SI system. The Newton meter is named as joule. What is joule? When 1 Newton force applied on the object got the displacement of 1 meter, then the work done is called 1 joule. So, the joule is the SI unit of work. To observe the above situations, the equation we use it W is equal F into S. F is a vector and displacement is also a vector quantity, but the product gives the work is a scalar quantity. Why the work be treated as a scalar quantity? The work has only the magnitude. It has no direction. That is the reason work is treated scalar quantity. In fewer situations, the displacement of object and the force applied are having same directions, but in many the displacement makes the angle with the force applied. Then the work done is written as Fs cos theta. Here theta is a Greek word denote the angle between force and displacement. This equation is used when displacement makes the angle with the force. The F cos theta is represent the component of force along the x-axis. Suppose the applied force has two components. The horizontal component of force be written as Fx is F cos theta and vertical component along the y-axis Fy is F sin theta. So that is the reason F cos theta is written in this equation. Finally concluded the equation of work is F S cos theta. The work is maximum when theta is 0 degrees. That is the reason for while direction of displacement and the direction of force are in same, the angle between them is 0, then cos theta is 1, then W is maximum. The work done is 0 when theta is 90 degrees. If the angle between force applied and displacement is 90 degrees, then cos 90 is 0. That is the reason W is 0. So in this condition, the work is minimum. There are three types of works. The first one is positive work, the second one is negative work, the third one is zero work. When the direction of force and displacement are in same, the work done in this situation is treated positive work. Here, the applied force increases the velocity of object and causes acceleration. In these situations, if the direction of force and displacement are in opposite, this work is treated negative. Here, the force applied slows down the velocity of object. For this, while we are driving car on the road, when we apply brakes, the car slows down due to the frictional force acting opposite to the displacement. This is the best example for negative work. And zero work. The force is making 90 degrees to the displacement, then the work done is 0 because the angle 90 cos 90 is 0, then the product f into s cos theta is 0, then the work done is 0. These are three types of conditions. Thank you.